Okay, today we're going to go over section 6.2, properties of parallelograms. So here we go. So a parallelogram is a quadrilateral with both pairs of opposite sides parallel. And now if we talk about the different parts of a parallelogram, first of all, the consecutive angles are angles right beside each other. Just like we talk about consecutive numbers like 1, 2, 3 are consecutive numbers, they're right beside each other. Same thing with consecutive angles. So the different pairs of consecutive angles would be angle A and angle B would be a pair. Another pair would be B and D. Okay, another pair would be D and C. And the last pair would be angle A and C. Okay, so those are our consecutive angles. It's just good to know the different parts of the parallelogram so then we can talk about them with the different properties in a moment. So the opposite sides are just sides across from each other. So like AB and CD are across from each other. Okay, so that's a pair of sides across from each other, and then AC and BD. Okay, and then the last pair that we're going to mention are opposite angles. So again, opposite means across from, so opposite angles would be like angle A and D and B and C. So we've got angle A and angle D and angle B and angle C. Okay, so those are different parts of a parallelogram. And now we're going to talk about the different properties of a parallelogram. So the first one says, if a quadrilateral is a parallelogram, then its opposite sides are congruent. Fix that G. Okay, so what that is referring to is that this side is congruent to this side, and this side is congruent to this side. Okay, if we look at the next property, let's switch colors here. It says if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Okay, and think for a minute what supplementary means. You know, back from chapter 1, we learned that supplementary are two angles that add up to 180. So I can't really mark that on my picture at this point, but just as a reminder, all of these pairs of angles must add up to 180. So these two add up to 180, these two add up to 180, these two add up to 180, and these two add up to 180. Again, the reason that works goes back to chapter 3, because if we know that it's a parallelogram and both sets of opposite sides are parallel, again, meaning like this side is parallel to this side with the arrows, and this side is parallel to this side, then if these two sides are parallel and this is the transversal, these two angles would be same side interior angles, which means they must be supplementary. Same thing, if these two are parallel and this is a transversal, these two would be same side interior angles and they would be supplementary. And that's true for all of these pairs. Okay, so again, that one I'm not necessarily marking on the picture, but that's something just to keep in mind. Consecutive angles are supplementary, which means they add up to 180. All right, next one says if a quadrilateral is a parallelogram, then its opposite angles are congruent. Okay, and that is something I can mark on the picture. I know that this angle must be congruent to this angle, and I know that this angle must be congruent to that angle. Okay, and then the next thing says that the diagonals of a parallelogram, let's see which color I want to use now. Let's see, we'll use that guy. Okay, so the diagonals of a parallelogram bisect each other. So we've talked about bisect earlier in the year. Bisect means cuts in half. So, you know, basically slices it in half. So these diagonals bisect each other, which means they cut each other in half. And it's telling us that AD bisects, so this one bisects this one, which is BC, and BC, this one, bisects this one. So, AD. Okay, and again, it makes the picture a little messy to add all this on here, but just to give you an idea of what's going on, if I do draw the two diagonals, it means that this piece is congruent to this piece, and it means this piece is congruent to that piece, okay? All right, so let me go ahead and get this cleared and we can move that up. Let me give you a chance to see that again if you need to. You can pause the video if you still need to get some of that down. And then we'll move from there. So, get this moved up. Okay, so now on example 1, okay, it says here to find the value of the missing variables in each parallelogram. So we're using the rules that we just wrote down to find some of the missing pieces here. All right, we just have x defined here. Again, if it's telling me it's a parallelogram, then I therefore know that these two lines are parallel to each other. Okay, if it helps you to extend them out, sometimes that helps people to see what's going on. Okay, this is the transversal. So I have to think, what do I know about those two angles? We just said consecutive angles are supplementary, which means they add up to 180. So I can just do the fact that x plus 115 is equal to 180. And so if I want to solve for x, I know that I can just subtract 115 from both sides, and that gives me 65 degrees. Okay, so not too bad there. All right, over here for B, there's different ways you might be able to start this. You might think, oh, okay, I know opposite angles are congruent to each other, so if that's 112, then this has to be 112. Okay, and I'm going to go ahead and write that off to the side, make sure you can see it. All right, and then for angle 1, you know, I can use the same thing I just did on part A. I can use the fact that, okay, consecutive angles are supplementary. So I know for the measure of angle 1 that I know I can do the, you know, x plus 112 is equal to 180, and I can solve, and I can get that x is equal to 68. Or angle 1 is equal to 68. Okay, and then once I find out something, I'm going to put it in the picture because sometimes that'll help me find the next thing. And then if I know that angle 1 is 68, I therefore know opposite angles are congruent, so angle 3 also has to be 68. Write that here so you can see that a little better. Okay. All right, on C, in this particular case, we are using the fact that, again, consecutive angles are supplementary for a parallelogram. So if this angle is 60, then I know that this whole angle from here to here must be 120, okay? So, because, you know, if you want to write it out, I can say x plus 60 is equal to 180, and I can solve and get x is equal to 120. Well, if I know that this whole angle is 120, and I know this angle is 60, and I want to know what this angle is, then I know that I can just subtract. You know, I can say measure of angle 2 plus 60 is equal to 120. So I know that measure of angle 2, therefore, must be 60. Okay, and so I needed to find that. If I want to put that in my picture, I can do that right here. And now I can use the fact that, you know, if these two lines are parallel, and I'll use a different color here, say this is a transversal, then I know that these two angles here and here, angle 1 and angle 2, must be alternate interior angles. And I actually just highlighted the wrong line, so let me fix that here. Okay, so sorry about that. Let me get that fixed. Okay, so I am referring to these two parallel lines. Both pairs are parallel, but I just highlighted the wrong one. In between the parallel line and transversal, in between the parallel line and transversal, these two are alternate interior angles, so they must be congruent. So if angle 2 is 60, then angle 1 must be 60 also. So I can include that as well. Okay? All right, now if we look at D, then again, different things going on. You can kind of do some of these things in a different order if needed. There's not just one set way to do that. But in this particular case, you know, the first thing I see is angle 2. I know that these two are a linear pair. That goes back to, you know, chapter 1. They're a linear pair, so they must add up to 180. So I can say that measure of angle 2 plus 78 is equal to 180. And I can solve for that, and I can get 102. When I find something, it's going to be helpful to plug that in the picture, because that might help me find the next thing. You know, if I want to use the fact that, all right, these are vertical angles. If that's 78, that's 78. I can do that, and I can fill that in. Even though they didn't ask me what that angle is, that's helpful to fill in. And then I can use the fact that, oh yeah, these form a triangle, these 3 angles. I know 2, I want to find the third. So I can use that triangle angle sum theorem, which says all the angles of a triangle add up to 180. Okay, so if I do that, I've got measure of angle 3 plus 78 plus 48 is equal to 180. Okay, and once I do that, I can solve and get 54 for the measure of angle 3. And I can fill that in my picture once I find that. All right, from there, let me switch colors here. From there, again, I've got my 2 parallel lines. I've got my transversal. So I know that these 2 angles must be alternate interior angles, so they must be congruent. So if that's 54, then this angle must be 54. Okay, and so I'll go ahead and include that down below here. The measure of angle 1 is 54. Okay, all right, and then one more in example 1. And this one is similar to the one that we just did. Again, you might think of a different way to start than I did, but the first thing I see is a linear pair here. So same as we started last time, I can use the fact that, let's switch colors, I can use the fact that measure of angle 2 plus 75 must equal 180. So if I solve for that, I get measure of angle 2 is 105. So that's one of my answers. And once I find something, I can stick that in the picture. Okay. From there, again, I see my vertical angles. So if that angle 75, that angle 75, because vertical angles are always congruent. Now I see my triangle. I know 2 angles. I want to find the third. I can use that triangle angle sum theorem again. So I can use the fact that measure of angle 3 plus 50 plus 75 must be equal to 180. And when I solve for measure of angle 3, then I end up with 55. Okay, and once I find it, again, I'm going to put that in my picture because that might help me find the next thing. Go and switch colors here. And now I'm looking at the fact that, okay, last thing I need to find is 1. I know these 2 lines are parallel for a parallelogram. I know this is my transversal. So I know that these 2 angles must be alternate interior angles and must be congruent. So if that angle's 55, that angle's 55 as well. And then I'm just going to write that below, that measure of angle 1 is equal to 55 degrees. Okay? All right, if we go ahead and move on to example 2, since we can see that one at the moment, then just to make sure that you can see these numbers, I'm going to write those a little bit better, numbers or expressions. This is 2D. Okay, down here is 22. I feel like it's a little bit blurry, so I'm going to write it. We've got 46 and 66. And I think that's it. So they're asking this, they're telling us it's a parallelogram again. They want us to find measure of angle PLM. Which if we look for that, PLM is this angle right here. Yeah, PLM is basically this whole thing over here. LMN is talking about this whole angle over here, and D. Okay, they're showing me a D right here, so I need to set up some equation to be able to figure out what D is. Okay, so if I go ahead and do that, then again, if I think about those properties of parallelogram, I know opposite angles are congruent to each other. So if I go and add these 2 up, I get that that is 112. Okay, and if this whole angle is 112, then this whole angle must also be 112 because they are congruent to each other. Okay, so I'm going to write it in my picture, but I'm also going to show it off to the side here. Oops, to make sure that is clear. Okay, then the next one I need to find is this angle. Again, one of the properties up above says that consecutive angles are supplementary, so these two must add up to 180. So I can say the measure of angle LMN that I'm trying to find plus this angle that I just found must equal 180. Okay, and if I solve, then I end up getting 68 there. Okay, so that's one answer, that's one answer. If I want to go and write this in my picture, I can. And then the last thing that I'm trying to figure out is what D is. Well, again, I think about one of the properties from up above. I know opposite sides are congruent to each other, so I know I can just set these two equal to each other. So over here, I've got that 2D is equal to 22, and if I solve, I get D is equal to 11 for that side length. Okay. All right, so I'll give you a second to finish that. Pause it if you need to get some of that down, and we'll move on to example 3. Okay, so on example 3, it says to solve a system of linear equations to find the values of x and y in each parallelogram. If you think about solving systems of linear equations, think back to Algebra 1. You can hopefully remember that substitution was an option, elimination was an option, and graphing was an option, but once we kind of use graphing to figure out kind of the idea of it, then we mainly use substitution and elimination. Okay, and again, some people have a preference of one or the other. Sometimes it's going to be best to decide just based on how the equations are already set up once you see them. So first of all, we need to set up our two true equations before we can start trying to solve the system of linear equations. So again, if they're telling me it's a parallelogram, I know all of those properties up above apply. Okay, and the pieces they're giving me here are pieces of the diagonals. Well, that fourth property that we wrote down up above says the diagonals of a parallelogram bisect each other. So that means that this piece is congruent to this piece, and it means this piece is congruent to this piece. I think it's helpful to mark those things on your picture because I think that's going to help you set up your true equations. So if I go and set up my two true equations, I can set these two equal to each other. So I wrote x minus 2 is equal to 2y. And then I can go ahead and set these two equal to each other. And I did y plus 10 is equal to 2x minus 9. Okay, so again, both equations have x and y in them, and I need to solve them. So I think that the way this equation is set up kind of lends itself a little better to substitution, so that's the way I chose to do it. If you would rather use elimination, that is completely fine. If you're going to use substitution, you need to get one of the variables by itself. It doesn't matter which one. Technically, it doesn't matter. Just sometimes some are easier to get by themselves than others. Okay, so I'm choosing to get this x by itself because there's a 1 in front, so it's easier to deal with. I could have chosen to get that y by itself. It just was a little bit more work to do that. So if I go and add 2 to both sides here, then I end up with x equals 2y plus 2. Now that I have that x by itself, if x is equal to all this stuff, then I know I can put all of this stuff in for x's place over here. I'm just going to draw an arrow to show where I'm taking it. Okay, now I'm going to rewrite this original equation with this put in for x's place. Remember, substitution is like the substitute teacher comes in place of the actual teacher because the actual teacher can't be here that day. So they're just putting something into something else's place. So I've got y plus 10 is equal to 2. Now I need to put parentheses around what I'm substituting in for x's place. So 2y plus 2, and then I need to finish it out with the minus 9. As you can see, there's no more x's in my equation. I substituted that out, and now I have all y's in that equation, and that's something I can actually solve. So to solve that, I've got y plus 10 is equal to, I need to distribute this 2, so I've got 4y plus 4 minus 9. I can go ahead and combine my 4 and my 9 together to get minus 5. And then now I'm just trying to get y's on one side, x's on the other side. So I chose to go ahead and subtract y from both sides. And I end up with 10 is equal to 3y minus 5. Then I went ahead and added 5 to both sides. And that gave me 15 is equal to 3y. And once I went ahead and solved from there, I ended up with y is equal to 5. Okay, so they asked me to find x and y, and I've now found one of the things I need to find. I need to now find the other. So to do that, I'm taking this 5 that y is equal to, and I'm going to take it and substitute it in up here and for y's place. So to do that, I've got x is equal to 2, parentheses 5, plus 2. So I get x is equal to 10 plus 2, which gives me x is equal to 12. And that is solving for x and y. Again, if I want to make sure that those are correct, I can take the 12 and plug it in for x's place, take the 5 and plug it in for y's place, and it should give me a true statement for each equation. Okay, I'm going to go ahead and clear that and move this up so I have plenty of room to work out this one, but same directions. It's still solving systems of linear equations for the parallelogram. Yeah, again, it's going to work out very similarly. You could even try this one right now on your own first, and then, you know, pause the video, and then when you resume it, you can kind of check it with mine to see if you got the same thing that I did. Okay, so on this one again, diagonals bisect each other, so those two are congruent and those two are congruent. And when I go ahead and write that out, then I can see, you know, y is equal to x plus 1. And I can see over here that 3y minus 7 is equal to 2x. Okay. So the nice thing about this one is it already says y is equal to x plus 1. That y is already by itself, so that lends itself really well for substitution. And I can go ahead and take that information and substitute it in for y's place. So when I do that, I've got 3 parentheses x plus 1 minus 7 is equal to 2x. Okay, from there I can distribute my 3. And I end up with 3x plus 3 minus 7 is equal to 2x. And from there, I can go ahead and say 3x minus 4 is equal to 2x. And from there, if I want to go ahead and subtract 3x from both sides, then I get negative 4 is equal to negative x. And from there, if I go ahead and just divide by negative 1 on both sides, then I'm left with x is equal to 4. So once I know what x is, then I can take this information and substitute it back in up here for x's place. And when I do that, I've got y is equal to 4 plus 1, which gives me y is equal to 5. And so again, I got x is equal to 4, y is equal to 5. If I want to take those answers, plug them back into the original equations to make sure that it equals out on both sides, I can do that as well. Okay. All right, this next little part, I guess let me show you kind of the property and the rule here, and then we'll move it up to actually work out these last few examples. They're pretty quick. This theorem says if 3 or more parallel lines are cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So all they're showing me here is that if these 3 lines are parallel, 3 or more lines are parallel, and I know that this piece is congruent to this piece, again, I know they're parallel because these arrows, then I know that this piece must also be congruent to that piece. Okay, it doesn't mean that all 4 of these pieces are congruent to each other. It just means if these lines are parallel and these 2 are congruent, then these 2 must be congruent also. Okay, so let me go ahead and get that erased and moved up, and we'll do these last few examples. Oh, good, you can see them all. Okay, so here for example 4, it says if AB is equal to BC is equal to CD is equal to 2. So again, I can see all my lines are parallel by the arrows. They just told me that all these are equal to each other and that they're all 2. So I'm going to put that in my picture. And now they're telling me that EF is 2.25, so I'm going to stick that in my picture. And they want me to say what EH is. So just be really careful on these. These are not hard, but sometimes it tricks people because they just don't pay attention to the question well enough. I know from the property we just talked about, the theorem we just talked about, that if these 4 lines are parallel and these pieces are congruent, that these pieces must be congruent. So I'm going to show that they're congruent by putting 2 marks on all of them. I therefore know if this one's 2.25, then this one's 2.25, and this one's 2.25. And the question's saying, what is this whole thing EH? So I know that EH then is equal to, you know, you can either say 3 times 2.25, or you can do 2.25 plus 2.25 plus 2.25, whichever way makes more sense to you. And once you get that figured out, it's 6.75. Okay? And then the last part here, example 5, says that in the figure if TU is equal to UV, so again, we can see our parallel lines. And we can see here that if this piece is congruent to this piece, then we can find all these missing links. So it wants me to find NM. You know, I know that this piece must be congruent to this piece, so if that's 4.5, that must be 4.5. So I'm going to fill that in here. Okay, QR, I can see that if this is 3.8, then that must be 3.8. So I'm going to fill that in, and I know QR must be 3.8. The next thing it wants is LN, which is just this whole length from here to here. So I know that's just 4.5 plus 4.5, which is 9. And then the last thing it's asking for is QS from here to here. So I know that's just 3.8 plus 3.8, or I can do 2 times 3.8, and that gives me 7.6. Okay, so that is it for section 6.2. You can let us know if you have any questions, and we'd be glad to help you out.